In today's math lesson, we're going to simplify radical expressions with variables. In this lesson, you're going to use the same rules to simplify radical expressions, but this time we also have variables. So what we find is that you can bundle up variables too. And just like before, you will have bundles outside in front of a square root with the leftovers still inside of the root. Here in example 1, we're going to simplify the square root of 18d. To get this process started, we say, hey, where does 18 come from? So you could have a couple of options here. It could be 2 times 9 or 3 times 6. Either way is fine. And then we see that 2 is prime, but 9 is not. So we break the 9 into its parts, and 9 came from 3 times 3. Now we also have a d, just a simple lone d. Let's look for our bundles and leftovers, remembering that a bundle is 2 of the same number. Here I have a pair of 3s. Yep, so this is a bundle. But I have a 2 with no one to bundle with, and a d with no one to bundle with. So these are leftovers. So from that, we can say, okay, up in the lesson description, I need a bundle in front of a square root with leftovers inside of the square root. So the representative of my bundle is a 3. Here is my square root. Leftover is a 2 and a d. Your coefficients always go in front of your variables, and these were multiplying together. They're inside of the root to begin with, so they are multiplying together as we finish it up. And there you go. In example 2, we're going to simplify the square root of 50p to the 10th power. Let's find out where 50 comes from. 50 has a couple of options, but one of them is 2 times 25. While 2 is prime, 25 is not, and it comes from 5 times 5. This time I have p to the 10th power. So let's write that out. So p to the 10th power is really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables of p. Let's see if we can find our bundles. So I have a pair of 5s, that makes a bundle, but I have a leftover 2. This 25 was broken, so I don't need to worry about it anymore. All of my variables p. Just like I needed a pair of 5s to make a bundle, I need a pair of the same variable in order to make a bundle also. So we see here I have a result of 5 pairs of p. Let's build our final answer. So I have a pair of 5s, and then I have 1, 2, 3, 4, 5 pairs of p. I have my square root due to having a leftover of 2. So how would I write this in the most simplified version? This would be 5, that's my coefficient out in front, and then due to having 5 of the same variable, I will have an exponent of 5 on my variable p with a square root of 2. And there you go. In example 3, we're going to simplify the square root of 20z to the 7th power. So let's break down 20. 20 can come from a couple of options. One of those options is 2 times 10. And 10 is also composite, and that comes from 2 times 5. Z to the 7th power, let's look at that. That comes from 1, 2, 3, 4, 5, 6, 7 z's. All right, let's go find our bundles. This time we have a bundle of 2s that's here on the side, and that's not a problem at all. This is still a bundle, even though it's in a slightly different location. And I have a leftover 5. I also have bundles of Z's. So I have 1, 2, 3 pairs of Z's with a leftover here at the bottom. In this particular example, I have multiple bundles and I have multiple leftovers, but we're still going to put them in the same final answer format. So I have 1 bundle of 2s, and I have 1, 2, 3 bundles of Z's. Here's my square root. I have a leftover of a 5 and a leftover of a Z. So to finalize this and clean it up, I'm going to put my 3 variables of Z together, giving me a final answer of 2Z cubed, as there are 3 of them, square root of 5Z. And there you go. In example 4, we're going to simplify the square root of 27t to the 3rd power. 27 doesn't have a lot of options of where it comes from. It's just from 3 times 9, and 9 comes from 3 times 3. I also have a t cubed. T cubed comes from 1, 2, 3 t's. So let's start finding where our bundles are. I have a bundle of 3s, and I have a leftover 3. I have a bundle of t's, and I have a leftover t. Let's see what our final answer is going to look like. So my bundles, I have a bundle of 3s, and I have 1 bundle of t's. Great. Square root, I have a leftover 3 and a leftover t. So our bundles look identical at this moment to our leftovers. And there you go. In our 5th and final example, we're going to simplify 2 times the square root of 27b to the 5th power. So this is a little different in that we have a coefficient in front of the root, but we're going to go through the same process of tearing apart what is inside of the root first. So 27 doesn't have a lot of options from which to come from. It's 3 times 9, and 9 comes from 3 times 3. b to the 5th power is 1, 2, 3, 4, 5 variables of b. So my bundles are here with 3s and variables of b. I have leftovers of a 3 and a b. But I also have this coefficient of 2 out in front. So let's look at that. So I have this 2 that is truthfully multiplying to the square root. And so it will here also be multiplying to my bundle of 3s. So 2 times 3, I have 2 bundles of b with a square root, leftover of 3, and a leftover of b. So let's clean this up for our final answer. 2 times 3, well, that's 6. b, well, that's b squared, times the square root of 3b. And there you go.